All right, this is the start of our next chapter, which is called 8.3. And the actual title of this chapter is A bracket X plus B equals C. So really, the purpose of this chapter is to utilizing or using distributive property, right? We're to practice using distributive property within slightly more complex questions, right? So remember in grade 8, you learned, actually was it grade 8 or grade 8. You learned something like 2 bracket X plus 1 equals 6. There's more of a question we did today. And you learned in grade 8 that you can solve it two ways. And I'll just copy this actually. I'll just take this and clone it, bring it over here. And you learned that you could expand it or you could use division first. Those were the two methods we talked about in grade 8. I'm going to show you how to do both. If you expand it, keeping in mind this is two groups of x plus 1, if I look at it, there's an x and there's a plus 1. There's an x and there's a plus 1. So this would be two groups of x plus 1. Or, if I think about what that picture actually represents, it's 2x's plus 2, right? And we would get that 2x plus 2 by expanding using distributive property. So we would say I have 2x's for 2x. I have two 1's for 2, and that's what it would look like if I expanded it. So therefore, I would have 2x plus 2 is equal to 6. Once I've expanded it, I now have a two-step algebraic equation, which I could subtract 2 from both sides. 2x equals 4, divide by 2, and my solution would be x equals 2. You also learned in grade 8 that you could use division first. So instead of saying I have two groups of x plus 1, we understand that this is an equation, so it's balanced. If I divide this side by 2 and divide this side by 2, I maintain equality. So if I divide this side by 2, instead of having two groups of x plus 1, I will have just one group of x plus 1. And over here, I'll have 3. Once I solve that, I would subtract 1 and subtract 1. And my solution is still the same thing I got over on the other side, x equals 2, but I took a slightly different path to get it. Okay. So the two methods you want to have in your notes for distributive property are expanding, using these ideas of the arrows to multiply each term of your, we'll use our polynomial terms, each part of your polynomial by the monomial outside the brackets. Or you can use division first by dividing by whatever that monomial is that you're multiplying the polynomial by to get rid of it and to simply have the polynomial itself. Okay? So with that said, if we look at the questions that we have here for our two exemplars, see if I can get rid of this. There we go. The first question says 2 multiplied by e minus 0.6 equals 4.2. The only difference between the one I just gave you and this one is our inside polynomial has a decimal for a constant as opposed to a whole number, right? But we could still solve it two different ways, and I'm going to show you both ways. So 2 bracket e minus 0.6 equals 4.2. Obviously, the first way is to expand. So we can say two groups of e, or 2e, minus 1.2 is equal to 4.2. Once you have that, you can add the constant to both sides to get rid of the opposite, or to create an opposite operation. You get 2e equals 5.4. And finally, dividing both sides by 2, e will equal 2.7. Okay? What method's that called? That is called expanding using distributive property, or expanding. Alternatively, what could I have divided both sides by on the other side, in the division first? If I divide both sides by 2, instead of having two groups of that, I'll have one group of it. Right? And that would be my much simpler equation. Now it's just a one step. Create a zero pair by adding the opposite constant, and I get e equals the same answer of 2.7. Now, the next question B is quite possibly the most interesting algebra experience you will ever, up until now, have ever encountered. Now, I'm going to draw this, I'm going to write this one twice as well. I'm going to bring it over here. I'll write it again over here. C plus 2 over 3 equals negative 5 over 2. We're going to solve this one two different ways. The first way, before I tell you what you like, how to do it a special way, what would everyone have done in this question first? What do you think the first step is going to be? If I was asking you to guess what my first step is. What is the constant? It looks like it's 2, isn't it? Right? But it's not. The constant is actually 2/3. Because remember, if you expanded this with distributive property, you really have a third of C and a third of 2. Remember that when we did polynomials? Really, that's what we have on that side. Because we have C plus 2, but we're dividing that entire C plus 2 by 3. Right? So because of that, your first step would likely be tripling this side. You see that? If I triple this side, again, keeping this idea of balancing, I'm going to multiply this side by 3. I'm going to multiply this side by 3. If I multiply the left by 3, what would I have left? What would I have left on the left if I left it? Those would be opposite operations, correct? I would have C plus 2. But I'd have to multiply 3 on this side as well, giving me negative 15 over 2. Now, some people are going to realize that negative 15 over 2 can be made into a decimal, right? We don't have to keep it as, since there's no fractions left except for that one, let's keep negative 15 over 2 as a decimal. What's that going to be? Negative 7.5. And look how easy this question suddenly became, right? By simply multiplying both sides by 3, I ended up with this, in which case I'm going to subtract both sides by 2, and C will equal negative 9.5. Okay? And that's what happened when we tripled both sides. That's what ended up happening. Okay? Now, alternatively, this is where it gets super awesome. I want you to consider what's going to happen here. Will that maintain equality if I do so? It will, won't it? We all understand that multiplying both sides by 6. Now, where did 6 come from? Why did I randomly choose the number 6? I looked at all of the entire equation and I realized this was a third, and this was a half. And if you think of it as fractions, what you need to understand is if you multiply any fraction by a multiple of its denominator, you will end up with a whole number. So for example, if I multiply 3/4 by any multiple of 8 or any multiple of 4, where did it go? Give me any multiple of 4. Give me another one. Let's go with 8. Let's just go with 8. So 8 is a multiple of 4. If I multiply that, right, I'm going to get 24 over 4, which is what number? 6. If I take that 3/4 and multiply it by 12, another multiple of 4, I will end up with 36 over 4, which is equal to 9. So anytime you multiply a fraction by a multiple of the denominator, you will end up with a whole number. So that idea, if I take that idea and apply it to this question, then multiplying both sides by 6 should create non-fractional sides. Does that make sense? Let's watch what happens. If I multiply this side by 6, and I multiply this side by 6, not the term, but the side. If I think about that, multiply the numerators, what am I going to get here? 6c plus, not 2, 6c plus 12. Why? Because it's 6 multiplied by c plus 2, which requires this, right? However, and this is where we told you that eventually cross reduction is very important, right? What if I cross-reduced it? What's 6 over 3 going to cross-reduce to? 2 over 1, right? Now look what happens to your denominator. Does it exist anymore? It's a 1, which means it doesn't matter. The only thing left is going to be the product of the numerators, meaning I have 2 multiplied by c plus 2 over 1, or 2c plus 4 when I expand it with distributive property. Over here, if I cross-reduce, what will that become? 3 over 1, correct? And again, my denominator is 1, meaning the product of my numerators is all that's left, which means, what's the product of the numerators? Negative 15. So look what happened. I started with this equation right here, right? All I did was multiply both sides by a common multiple of the denominators of 3 and 2, and it was 6. And by doing so and cross-reducing, I ended up with a grade 8 simple question. Subtract 4 from both sides. 2c equals negative 19. Divide both sides by c, or by 2, sorry. And c equals 9.5, or negative 9.5, which is the same answer I got over here. Let's try a different one.